in an object actually oriented context, and basically when we are talking about the use of the C++ as programming language to manage the strings, characters, what we are actually covering under all of the umbrella of strings. We have to recognize that the value of the string or the character in memory, it is a sort of ASCII representation. It's a binary value. So it's a digital, let's say, representation that we have to manage somehow. The context of the management here is to allocate space and later on to maybe display or let's say retrieve, update, concatenate, all the activities we may think of to render the value into something that the user can understand, read, or write. Let's say we human beings can understand. We will not be able to manage the binary values, the hexadecimal values or something like that. No, we will manage only what we can read, the alphanumerical content, maybe symbols also. Thus, we have to have actually a sort of correlation in between the background value and the front end value. Background, actually, what the processor sees, what the memory sees. Foreground memory is what we read, what we humans can understand. Full stop. Full stop. That's the full scenario behind the characters management or the strings management. To have a correlation in between the back end values, ASCII binary, or what all the processors and memories can see, and what the front end, what we humans can see, the text and the alphanumerical values. Correlation in the sense of when we make actually a concatenation, for example, concatenation of two strings, hello, fox, one word, sorry, one phrase. If they are segregated in the memory, we will have to, let's say, correlate the binary values, or let's say at the end of the day, the ASCII values here, the ASCII values. If you can see my my cursor, into something that actually can be rendered into what the human can read, something like what you are seeing here. Computer cannot understand what is this one actually, hello world or the fox. He cannot understand this thing. He has to understand, or he can understand only binary values that actually have been retrieved from this original, let's say, media, or let's say this string here. All the characters, all the strings in a scenario of managing them over the memories have to be terminated with the special character, which is the \0, to indicate that the string in question has been terminated. Even if it's one character, the size would be 2 characters. If it is one character only, a string is made up of, for example, of one character, A. The computer will store 2 characters, the letter A and this termination character, the \0, to indicate that the string has been terminated. For future, let's say, references, whenever we refer to this string, to see the limit or the end of the string, we have to see this / character, no more no less. Referring to a string in a computer, we have to actually manipulate list of characters. The string is the data type that actually annotates those lists of characters. Yet it would give us actually one value made up of a list of characters. We will not be able to point those characters one by one as easy as if we are referring to them using an array of characters. See here, blue, B-L-U-E. This is a list of characters, but it's one word, blue, the color blue, but it is stored in an array of characters. It is a string terminated with this \0 character, sorry. We will be able to point each character one by one, manipulated later on one by one without any issue, because of the capability of the array, or what the array can give us as capabilities. Can we use a string to store this blue in a character, in a variable? Yes, we can. But later on, depends on the scenario. Usually, it's not. This is not actually a matter of comparison, but it is one of the solutions. So in a question, or say in an exam or something like that, if I would ask you, or the question asks us to clarify which is better to use the data type. Is it the character data type or the string data type? There is no comparison here. Which one is the best? But which one fits the answer of the question in question? So it depends on the scenario. There is no one is best. No, one is much more better for the solution in question or for the question required. So it depends on the question. We choose this or the other, the data type, char or string. Actually, this is actually the context of the declaration, an area of characters. And then here, the affectation, we are just initializing this variable, the area of characters. So declaration, initialization, and then after the bring of the output, scene word. This is an output. This is an output. Simple. There is no indication here of which character to be brought in output. Simply just write in the word the variable name. In this example here is word 20. It would hold 20 characters. So in word, the full content of this variable would be actually printed in output. The scene here, it is one of the actually one of the, let's say, predecessors actually that we can use in C++ to bring an output on screen. But when we deal actually with strings, there is a dedicated predefined method responsible for reading, let's say, values and display them in lines altogether. Because here, if we are having spaces, there will be actually a problem in displaying them in just one line or something like that. So this is actually this predecessor here, this scene, it does not fit usually the output. This is actually this is a compiler problem. Whenever we deal with the scene, we will have different views from a compiler to another, from a platform to another, when we deal with characters using scene to bring an output. So there is a dedicated predefined method for the characters themselves, for the strings, to bring them actually as they are. If we have a phrase or, let's say, a list of words separated with spaces, they would all be displayed as they have to be here. See here, see this example here. So we are bringing a phrase that is made up of a long, let's say, number of characters, and we just utilize the following syntax here. It's a scene for usual, but get line here means we're going to have the full values segregated with the spaces or whatever the segregation character, all in one line only. Get line. An example program here, actually, you may look at that. Come back. Okay, we talk about the predefined methods. Actually, at the beginning, we said that there are predefined methods responsible for, let's say, the manipulation or the processing of characters or strings. We're going to do a list of activities, and those activities, they are not to be done manually from the scratch, or let's say from scratch. We refer to an assistance that predefined methods can give us. We can look at those here, the str string, CPI copy, str cat concatenation, str CMP compare, str length, and so on. So they are not unique, but those are the very famous and famously used, and they are actually repetitively faced to solve solutions, solve problems actually. Starting with the first one, there is no order here. There is no first, second, third, none. It's just a matter of predefined methods, list of predefined methods. We're going to define them to use them accordingly. No question of order here. The strcpy, the string compare, the string copy, we are going to copy a value in a variable, which is in a character or let's say a string, into another variable. This strcpy uses two parameters. It's a predefined method. The parenthesis is the indicator, and inside we have two parameters. Parameter number one here is the S1, and parameter number two is the S2. So what we are going to do is to copy the second parameter into the first parameter. So the strcpy here in this example, it would copy the S2 inside the S1. Example, we have actually, an array of characters, 100 characters. Here it has actually Muhammad Ismail, it's a name, something like that. We are going to copy this value from the S into a second variable, which is actually also an array, f name, first name. It's not initialized here, it's declared only. Here it's declared and initialized. So strcpy, f name, s is the second parameter, since it is going to be utilized to copy its value into the first name. So the first name is empty, is the first parameter. The first parameter here. Another predefined method, which is the concatenation method. We're going to bring two characters, let's say, or two words or two phrases side by side, concatenate, to link them side by side, concatenation. Let's see that. Also, this one utilizes two parameters, first string and second string. And as you can notice here, we're using a character. We are not using string, but it's a character, it's a pointer of character, it's a pointer. So the pointer can play the role of an array. The pointer can play the role of an array. Two parameters, S1 and S2. The same thing here. There is no first in second or second in S1. No, they would be actually brought in an S3 side by side, S1 and S2. Let's have an example. See here, str cut, f name, l name, first name, last name. The first name, what is it? It's Muhammad Ismail. L name, what is it? It's Al Abri. So actually, we have two words here in the first name and the f name, and we have one word, or let's say also two words, Al Abri, in the last name. So 4 words. The output, if you can hear, if you can see here, actually the down of the screen here, my full name is Muhammad Ismail Al Abri. It's linked here, Muhammad Ismail Al Abri here. So here it is. Here the see out. My full name is f name. F name. What is it? It's the content of this first name plus this L name. Concatenation. To count the number of characters inside actually a string, or to count the number of characters inside an array of characters, we have more than one solution, not only one. We have more than one solution. One of the very famous predefined methods that would actually be utilized to count the number of characters inside a string is the strlen, string length, strlen, string length. Yeah, actually, this one actually utilizes only one parameter here in this example. It utilizes one parameter, which is the string to measure its size, and it would return a number. And the number here is the length of the parameter passed to the string length. See here the example. We are passing the one parameter to the string length, which is the first name. The second here, last name, L name, stored in the S1, stored in the S2. What are those two, S1 and S2? They are ints. They are ints. They are numbers. S1 is a number. S2 is a number. So strlen uses a string as a parameter, but its return is a number. It returns a number. fourth method, which is the compare, strcmp. Two parameters here to be passed to this strcmp to compare. We're going to compare now. So at least there are two. We're going to compare the first string with the second string. The return of this predefined method is a number, so still it has to say actually the matter of the comparison here. It will not say that this is a French language and this is an English language, or this is an Arabic language and this is an English language. No, it's not this way. It will compare if they are the same or not. Plus, if they are the same, okay, perfect. If they are not the same, it would return a value to say the first one is longer than the second, or the second one is longer than the first. The comparison to say that they're actually the same. If not, it would return the condition. Actually, it's a decision to make. Which one is longer, the first or the second? strcmp, string compare. Two parameters to be passed. Let's have the syntax. Here, this S1 and S2. String number 1, string number 2. Let's have an example here. S1 is an array of characters, orange. S2 is an array of characters, also, apple. S3 is banana here, but we'll use that later on, something like that. S4 is empty. S4 is empty. Okay. We have ints D1, D2, and D3. As I said earlier, the strcmp returns a number. If 0, so the two strings, they are actually equal. If 1 or -1, positive or negative, we will see actually cases. The example here, actually, we are going to compare those two, S1 and S2. Let's have the here this is the syntax. We are going to store the result in the D1. D1 is a number. Here it is. D1 is an int, so it's a number. The comparison of S1 and S2 is D1. The comparison of S2 and S3 is D2. The comparison of S1 and S3 is D3. D1, D2, D3. Let's see the output. Here, comparison of S1 and S2 is 1. Comparison of S2 and S3 is -1. -1, here it is. Comparison of S1 and S3 is 1. Enter your favorite fruit, orange, your search is found. Something like that. Actually, it's the program here. But what we're going to conclude here is that if they are the same, we would have been actually seen 0 in output. Apple and orange, they are not the same. And even the number of the characters, they are not the same. 6 characters. Here we have 5 characters. So they are different. S1 is longer. S1 is 6 characters. S2 is 5 characters. Thus, the comparison of the S1 and S2 is 1, positive value. Positive value. Comparison of S1 and S3, where it is? Sorry, S2 and S3. S2 and S3. Where is the S3? The value of the S3 is banana. 6. Yeah, 6 characters. S2 is 5. Apple, 5 characters, and this is the second. Is 6 characters. So S2 is 5 characters. S3 is 6 characters. First one is shorter. So the value is -1. Is negative. We may have a different value, but it's a negative value. Negative value means the first one is shorter. The second one is longer. I hope that it's clear. Actually, it's not complicated. 0 if they are the same, with the same length. Positive value if the first string is longer, negative value is the first character is shorter. And that's it. That's it. So this context of the strings, we finished that. I told you in an early age to, even the same way, actually, I'm going to ask you to try to solve this thing here for tomorrow's class. For tomorrow's class, not for today's lab. For the lab today, actually, we'll be having. Our lab is tomorrow, not today. Okay, so you have the chance to solve those tasks, and we solve them and correct them together tomorrow. I'll give you this recording actually.